All right, so as I was saying before, we're back into circuits, but now what we're going to do is combine our three values, our three types of values, our voltage, our current, and our resistance, and we're going to use those and the things, processes that we've already talked about, Kirchhoff's voltage law, Kirchhoff's current law, how to calculate resistance. We're going to use all of that information to solve circuits. And so start off with a nice easy one here. And again, these circuits are like a puzzle, which I always find interesting. And much like a puzzle, you don't know which piece to put in first or try first. And so in this case, we have a VO. We also have a R naught, I should say, and an I naught. And so those are the current coming from the battery, the overall resistance of the circuit, and the voltage coming from the battery. And up here, R1, that's our first load. It has a certain voltage required, and it has a certain current required. So I'm going to call those I1 and V1. And then we have our second, I guess, load, you could say, down here. So I have an I2 here, so I'm also going to need my V2 and my I2, or sorry, R2. All right, so those are all the missing information. Now, what I try to do, like I said, it's a puzzle. I try to find out the easiest thing first. Now, this here, like I said, is a nice simple series circuit because there is just one path for the charges to go by. And so I see down here I have an I2 of 4.5 amps. Now, again, charges, that is the current is the amount of charges going through the circuit. And so if there's 4.5 amps going through this second load, well, there must be 4.5 amps going through the first load. And that also means that there's 4.5 amps coming from the source. All right, so I've already found out quite a few values there. What else do we have? Voltage, 90 volts. All right, that's not going to help me. But when I look at, when I have a lot of the information here, say in our first load, I have R1 and I have I1. Well, what I can use is my formula, V equals IR. And again, that's Ohm's law that we just looked at. And so I can find my V1 because I know that V is equal to, let's see, the current is 4.5. And I times the resistance, which is 12 ohms. And let's see, if I multiply those two, I get 54 volts. And so, well, that's a piece of the puzzle here is I got 54 here. All right. So now that helps me solve. I've got everything I need for load one here, but that helps me here because I know 90 volts come from the source. And so if 90 volts are leaving, and again, that's the amount of energy per charge, and 54 of them get used up on load number one, well, that means then that in load number two here, I just take 90, subtract 54 to find out how much is left, how much energy is left. And let's see, I take 90 minus 54, I get 36. So 36 volts are used there. All right, what else am I missing here? RO and R2. Well, again, I can use my formula to find R2, where in this case, my R, again, Ohm's law, is equal to V divided by I. So in this case, let me see, my V is 36 divided by my I, which is 4.5. And I end up with, let's see here, 36 divided by 4.5. I get 8 ohms. All right, so there's an 8 there. Again, it's a puzzle. I just try to figure out what I can. There's no particular order here. Now, what's the last? Oh, RO. Well, we have a series circuit here. And so when you have a series circuit, you just add up the resistance. So I have a 12 for R1 and an 8 for R2. And so if I add them up, that means the equivalency here is 20 ohms. And now I found the V, the I, and the R for every single load in the circuit, including the source. There we go. So again, I bounce between using Kirchhoff's voltage law and current law, and also using Ohm's law, which is the V equals IR, or it can be rearranged to look many different ways. Again, this is just like a puzzle where you don't know where the start is. You just try to figure out what piece is the easiest one to get to next. All right, so let's try another one. We're going to do a few examples here. All right, so again, we're looking for all the different information. We have our R1, R2, R3. All right, this here is our VO, which is 9 volts coming from the battery. I'm also going to need the IO and the RO. Okay. And the same thing for all of these loads, the 3 loads. Now, I have a parallel circuit inside a series. And so what I can do when I'm looking at this is, I guess the first thing is I can find R23, combining those 2 circuits to find out what my resistance would be if I combine them, because then I'll be able to figure out RO. All right, so again, because it's in parallel, I got 1 over 20. All right, plus 1 over 30. And then I have to take it to the power of -1. All right, so let's see here. Whoops, I'll go down here, I guess. 1 over 20, that's a small number. That's 0.05 plus 1 divided by 30. I get 2 decimal places here, 0.03. All right, I take that to the -1. So I add those 2 together to the power of -1. I get 12 amps, or 12 ohms, sorry. There we go. All right, so now I can figure out RO, because RO, or R naught, is going to be, they're all in circuit, so I'm just going to add R1. They're all in series, I should say, and R23. Means I'm going to take my 6 ohms and add my 12 ohms, which of course then means that my R naught, the resistance within the whole entire circuit, is 18. All right, so I put that down here. So I've got my 18 ohms. Now look at this. I've got my, when I look at my source, I got the V, which is 9-volt battery, and I got the R. Well, now I can find the current coming from the source by, again, using my formula, Ohm's law here. So I have I is equal to, let's see here, I'm going to draw my triangle over here where I got volts, I down here, R in the corner. And so if I'm finding my I, it's V divided by R. All right, which in this case, my V is 9. My R is 18. And so the current coming from the source, again, the current's in number of charges, is 0.5 amps. All right. So there we go. I got that piece, 0.5 amps. Now, that means 0.5 amps leave this circuit here, and that means they have to go through the first load. All of them do. 0.5 amps. All right. Now, that means actually I can find the voltage, because again, I have my V equals IR formula, or my Ohm's law triangle here. And so because V equals IR, I can find the voltage going through the first load. So again, V equals IR. Whoops, there we go. And so the voltage here through the first circuit, I'm going to have, let's see, 0.5 times 6, which of course is equal to half of 6 is 3. All right, so I just found another value, 3 volts. All right, so I've got load 1 complete. I've got the source complete. Now I'm going to R2 and load number 2 and load number 3 here. Now, 3 volts, voltage law, 9 volts. That's the amount of energy each charge has. 3 get used up on load number 1, and then your charge comes to a junction point here at my maroon dot or purple dot. And then the charges can either pick load number 2 or load number 3. Well, no matter which load they pick, there's only 6 volts left, right? Because 3 are used in load number 1. So that means V2, you have to use 6 volts down this path. And V3, you got to use 6 volts down this path. All right, because no matter which path the charges go through in the entire circuit, they got to use up 9 volts. Now look at, we have V and R for both of these circuits. So I'm going to use, again, my Ohm's law formula to find the current. All right, because again, current, looking at my triangle, let's see down here, I equals V divided by R. All right, and so for load number 2, let me see, the voltage is 6. The resistance is 20, okay? And so if I figure that out, let's see here. We have volts is 6 divided by 20. Not sure what that is. Let's see here. 6 divided by 20. I get 0.3. 0.3 amps. All right. Now, here's the thing about a puzzle. Often there's a couple ways to look at this. All right, now I could use my formula once again to find I3, but I don't really need to do that because look at this, the current law. I can use Kirchhoff's current law. 0.5 amps are coming into this junction point. If 0.3 are used on load 2, and that means 0.2 is used on load 3. So I don't even have to use Kirchhoff's or Ohm's law to figure that out. I could though. Let's see if it's the same thing. It should be, right? A voltage is 6. This time I'm dividing my resistance for load number 3 is 30. And if I take 6 divided by 30, guess what? Sure enough, I get 0.2. So I had 2 options there. I could use Kirchhoff's voltage or current law to figure out the amperage going through load number 3, or I could use Ohm's law. Again, there's multiple ways to do this. But now you can see I've got the voltage, current, and resistance for both the source and my 3 loads. So I'm done. All right, so let's get it. Let's try a couple more here. Here we go. So now what do we got here? We got a series circuit inside a parallel. All right, so there's my source, 5 volts coming from the battery. So I'm going to need I/O, and I'm going to need RO. All right, so I already got my VO. Again, I'm just going to write it down here. It's 5. So what else can I find? Well, all I got here, other than the voltage coming from the source, I've got the resistance. So I'm going to find RO. But the first thing here is I've got R2 and R3. Now, they are in series, which is always the easy one. So I can find what's called R23, combining the two, and simply because they're in series, I just have to add them. And so my R23 is 40. All right, now what I want to do is find RO. And so to find RO, I guess we'll do that over here. I'm going to take my R23. Now they R23 and R1 are in parallel, so I have to use my 1 over formula. So I got 1 over 40. That's my R23 plus R1, which is, it's 42. All right. And then take that to the power of -1. All right. So what do we get here? RO. We take, 1/40th. Here's a good example of, again, figuring things out differently. 1 over 40 plus 1 over 40 is 2/40ths. To the -1. And again, I could put that into my calculator, but I know to the -1 is really just flip it. 40 divided by 2. And well, that means my RO in this case is just going to be 20 ohms. All right. Now I've got a V and an R here. So again, I can find IO because I can use my Ohm's law formula. And if I look at my triangle or use my triangle, V divided by R, that's how I'm going to find my current. And so I got a 5 divided by 20, which is should be just 0.25. Let me see, which it is, 0.25 amps. Okay. So there we go. I got the source all figured out. All right, so now what else can we figure out? Oh, let's look here. I've got R1. I'm going to need I1. No way of figuring that out yet. I need V1. All right. Here's something. And well, hold on. Let's label these first here. Let's not jump the gun. I need I2. I need the current going through here, and I need the voltage used up by this load. The same thing here. I need an I3 and a V3. All right. So let's see here. Now, voltage here. Here's something is that 5 volts leave the source. Again, that's the amount of energy. Now, if they pick path number 1 here, it's got to use up 5 volts because that's the only load it's going down. So it's got to use up all its energy on load number 1. Now here again, I got the V and the R, so I can find I1. Again, I1 is equal to V over R, so I got my 5 volts divided by 40. My resistance. And so if I take 5 and I divide it by 40, I get 0.125 amps. All right, so I'll put a 0.125 in here. Now, again, with current, this helps me figure out things because my current coming from the source is that 0.25 amps leave the source. 0.125 of them go down this path. The rest of the current goes down the series here that goes through load number 2 and load number 3. Now, if I take, let's see here, I3, if I take my 0.25 and I subtract 0.125, I'll get the current that goes down load number 3. And in fact, it is actually half of it goes down one way and half goes down the other because it's 0.125. So there we go, 0.125. And now if 0.125 charges go down load number 3, well, 0.125 charges go down load number 2. All right, now we're almost done here because I need V2 and V3. Well, all I'm going to use for both of these is V equals IR, again, Ohm's law, current times resistance. And so if I take 30 times 0.125, I end up with 3.75 volts. All right. Now, again, this is an option here. I can do V equals IR here to get voltage number V3, or I can realize the fact that 5 volts come from the source. And so if 3.75 of them get used up on load number 2, well, that means that 1.25 of them get used up on load number 3 for a total of 5 volts. Because if it does pick this, if the charge picks this series path where it's going to go down load 2 and load 3, it's got to use up 5 total volts. And so 3.75 add up to, 3.75 volts plus 1.25 volts would add up to 5. Now I can double check this by taking V equals IR. So I take my 0.125 and I times it by 10 ohms. And guess what? Yeah, of course, I get 1.25 volts. All right, so again, we've got the voltage, the current, and the resistance all for the source and for the 3 loads. All right, one more here. Again, just like a puzzle. Let's see what we get here. All right, so we got a 45 volt battery here or source. We have an R1, R2, R3, R4. Okay, so again, we're going to need to find all of the different values. And so, well, again, my VO is 45. I know that. Don't know how much current's coming from the source yet. And I don't know what the resistance of the source is just yet. But I am going to figure it out because here's what I'm going to do. I'm going to put R2 and R3 together because they are in parallel. And then I can use that information to find out the resistance, equivalent resistance for the entire source. So again, I'm going to find R2, R23 it's called. All right. And again, because they are in parallel, I'm going to have to take 1 over 20 plus 1 over 80. Oops. And then take the inverse of that. So let's see here. So R23, what am I getting here? 1 over 20, that's a small number. It is 0.05, okay? 1 over 80, I get, let's see here. Ooh, I'm going to go right to a bunch of decimals here because I want to get this accurate. 0.0125. All right, so I'm going to have to add those numbers up and then take it to the power of -1. And I end up with, let's see here. Oh, I get 16 ohms. All right. Now, I can use that information because that's the equivalent of R2 and R3 being combined. And so my series resistance, R0, is going to be equal to R1 plus this R23. Those are in series here. I'm adding them up, and plus R4. All right, so we get 10 plus 16 plus 4. Which equals, wow, 16 and 4 is 20, 10. We got 30 ohms here. All right, so again, filling in the puzzle. There we go. We got 30 here. Now I got my V and my R, so I can figure out how much current comes from out the source by, again, using Ohm's law. So I'm going to take I, and that is rearranging that formula or using my triangle. I get V divided by R. So it's 45 divided by 30. And again, this is for IO. And 45 divided by 30, I think it's 1.5. Let's see. Yep, it is. 1.5 amps are coming from the source. All right, so there we go. 1.5 amps. Now, what does that mean? How does that help me out? Well, again, current is the amount of charges coming from the source. And so those charges don't have any choice here on load number 1. They all have to go through load number 1. So I1 is 1.5 amps. Then they get to, again, I'm going to draw a purple spot here, a junction point where they have to pick. The charges either go down R2 or R3. I don't know which. But when they come out, they have to go down I4 or load number 4. So I4 has to be 1.5 amps. Okay. Perfect. All right. Now, how is that going to help me out? Well, I have got an I and an R here on both load number 1 and load number 4. So I can use my formula, V equals IR, to find the voltage through both load number 1 and load number 4. So V4, well, let's see here. I'm going to take 1.5 times 4. I think that's just 6. And it is. So 6 volts get used up on load number 4. I'm going to do the same thing here for V1. Again, V equals IR. So I take 1.5 times 10. Well, that is 15 volts. All right. Now that information, because I'm going to use Kirchhoff's voltage law, is going to help me find both V3 and V2. Because 45 volts come from the source. Well, 15 get used up here on load number 1. Then they go down either V2 and V3, and then they come out with a certain amount of energy, and they use up 6 volts. Now, no matter what happens, V2 and V3 are going to be the same because our charges have to come back to the source with no energy left. So if we start with 45, well, you subtract 15 from load 1, so now we're down to 30. And then 6 are going to be used up on load 4, so now we're down to 24. Well, that means that 24 must be used on V2 and V3. There we go. So now what's left over? Well, all we're trying to figure out now is I3, the current, All right, and I2. Now in both those cases, I don't have, I can only use it once. I don't, we'll see here. I'm going to use my Ohm's law, where I'm going to use I equals V over R. So if I'm doing I3 here, let's check it out. I got 24 divided by 80. No idea what that is going to be. So let's see here. I take 24, divide by 80, and so the current going through is 0.3 amps. All right, so again, if there's 1.5 amps coming to this junction box, 0.3 decide to go down load, or 0.3 are required to go down load number 3. Well, then I2 has to be the rest, which is 1.2 amps. Now, of course, I could have figured that out using my I equals V over R formula. So I would take 24 divided by 20. Guess what? It is 1.2 amps. So again, there's multiple ways to figure things out sometimes. And again, there's no order. It's like a puzzle. You can start on one corner. You can start on the middle. Sometimes you don't have a choice. You do have to figure out where to start. But that, again, is combining our Ohm's law, our Kirchhoff's law, and our Kirchhoff's voltage